All right, so the next category is combined radicals / fractional exponents. So for here, we have to use the properties of exponents to determine the value of a for the equation that's, and I'm not going to read it, but just note that we are only going to put in the a value for this category. So I know that's kind of confusing for some students, but I just want to remember or remind you that it says determine the value of a. So in the answer box, we're only going to put a. Okay, only put the a value. Okay, so in order to find our a value, we want to convert everything into exponential fractions. Wait, fractional exponents. Sorry, fractional exponents. So like I said, fractional exponents. So we have x to the power 1/5 on the top. That's already a fractional exponent. But on the bottom, we don't have a fractional exponent. We have the square root of x. So that would be x to the power of 1/2. 1 because there's a 1 over here. I know it's invisible. And over 2 because this is a square root. So invisible too, I know. But x to the power of 1/2 is the same thing as square root of x. And so we're going to simplify this. Since we have exponential divided by exponential, and they both have the same base of x, so it's x to the power of something divided by x to the power of something. This will be x to the power of 1/5 minus 1/2, top minus bottom, top fraction minus bottom fraction. And so whatever 1/5 minus 1/2 is, that's going to be our new exponent. So it's going to go over here, but right now I want to show the work for that on the top because it's more space. So 1/5 minus 1/2, I'm just going to kind of do that work up here. Okay, so 1/5 minus 1/2. So when you subtract two fractions, you want to make sure they have the same denominator. Right now, our denominators are 5 and 2, which is not the same number. So we need to find out what can we make that denominator. Well, we can make it a 10 because 5 times 2 is 10. So I'm going to multiply this one by 2 over 2. I'm going to multiply that one by 5 over 5. So on the left side, we have 2 times 1 gives us 2. 2 times 5 gives us 10. On the right side fraction, we have 1 times 5 gives us 5. 2 times 5 gives us 10. Okay. So we have 2/10 minus 5/10. And so now that they have the same denominator, we're going to keep that denominator at 10. And then across the top, you can just subtract 2 minus 5, which gives us -3. So then we're going to put that right over here, -3 over 10. So x to the power of 1/5 minus 1/2 is the same thing as x to the power of -3 over 10. Okay, so before I go in here into the answer box and type this as my answer, remember that we only want to put our a value in, okay? So only put the a value. And so what is our a value? Well, I was going to point and then I was also going to highlight, so I did that. I'll just point. A is our exponent, so we only want to put the -3/10 in there, okay? So in my answer box, I'm going to put -3 over 10. If you are one of the students that tends to forget when you're putting the a value, like make it in a big starred note, like put arrows pointing to these words. For this category, you only put the a value because it says right here, determine the value of a, okay? So that means in our answer box, we're only putting the a value. Okay, any questions? I'm going to pause the video so you guys get a chance to ask. Okay, so -3/10. Okay, let's do another couple problems from this category. All right, use the properties of exponents to determine the value of a for the equation. And then they give us the equation. So just to remind you, determine the value of a. So only put a value. Okay, so now with that reminder, let's convert all of this stuff into exponents instead of radicals. So x to the power 5, that's already in exponential form, so that's just x to the power 5. Now what about 4th root of x? Well, that is x to the power of, well, I see a invisible 1 there, over 4 over here, so 1/4. X to the power 5 times x to the power 1/4. So we have two exponentials that have the same base and they are being multiplied together. So therefore our fractions or our exponents have to be added. So 5 plus 1/4. Okay, so whatever 5 plus 1/4 is, that's going to be our new exponent that's going to go there. But I'm going to show the work for it up here because it's where I have space. So 5 plus 1/4, I'm just going to show the work for it up there, and then whatever answer we get, we can put it as our new exponent. So when you're adding 5 and a fourth, well, it's a little bit harder to add a whole number to a fraction, so let's convert it to fractions. So 5 is the same thing as 5 over 1. And then now we can just add fractions. For our fractions, they don't have the same denominator yet, but I can make this one have a denominator of 4 by multiplying it by 4. So 4 times 5 on the top is 20. 4 times 1 on the bottom is 4. And then the 1/4 just stays as a 1/4. So we converted the 5 into a 20 divided by 4, because 20 divided by 4 is 5. And we did that because 5 got turned into 5 over 1, and then we forced it to have the same denominator, so it's 20 over 4 plus 1/4, therefore giving us 21 on the top, because 20 plus 1, and then just the 4 on the bottom. So we're going to take that number and plug it in right there, 21 over 4. Now, before I go ahead and enter this into my answer box, remember, once again, that for our answer, we only want to put the a value. So what is our a value? It's right over there. I can't highlight it because it's just going to block. It's the exponent, so we're only going to put 21 over 4 into our answer box. Okay, so 21 over 4 is our answer for this one. Are there any questions? I'm going to pause the video so you guys have a chance. So 21 over 4 goes into our answer box. 21 over 4. Okay, and let's do another one. Use the properties of exponents to determine the value of a for the equation that. And once again, we're going to only put the a value. I'm just going to emphasize that again and again. Oops. Okay, so only put the a value. So now let's look at the problem. It looks pretty similar to what we just did. So there's one that already is in exponential form, so I'm just going to write that again. And then there's one in radical form. So let's convert that. So it has a base of x. There's an invisible power of 1 over here over the 5. So it's 1/5 and 1/5. So we have two exponentials being multiplied. That means we're going to add their exponents. So 1/5 plus 1/5. And in this case, I don't need to show the work up here because 1/5 plus 1/5, well, they both have the same denominator already. So luckily for us, it's more straightforward. It's still over 5, but on the top, we can add it straight across. 1 plus 1 is 2. So we have x to the power of 2/5. Now I'm not going to go x to the power of 2/5 over here because we are only putting the a value. And our a value, let me just highlight it just like I have been doing, it's right here, 2/5. So I'm only going to put 2/5 in here. Are there any questions on this one? I will pause the video. All right, let's enter in 2/5. Okay, and then let's go on to the next category.